Hello, my name is Oliver Stiewe. I would like to present a joint work between the Fraunhofer IAF and Fraunhofer HHI, where we are showing an experimental demonstration of a high-capacity THz-Wireless dual-link transmission system. And we assume that for future THz-Wireless communications that we need to use multi-link transmission systems, so beyond point-to-point systems. And therefore we take a look at two use cases, namely THz broadcast and THz unicast. So THz broadcast would be the case where we distribute our data signal to multiple access points at the same time, and THz unicast would be based on time multiplexing, so only one access point at a time will be supplied. Therefore we demonstrate a high capacity dual link prototype system at 300 GHz carrier frequency, and there we created a little setup where we have two spatially separated downlink connections, where we can do high symbol rate single carrier modulation and also have a burst mode capable DSP, offline baseband DSP. And we also have a uplink connection which uses BPSK modulation, where we use a FPGA-based receiver front end. So for the downlinks we used 4-QAM modulations. Data rates of up to 50 gigabit per second are possible. They are offline processed. And in the uplink we use BPSK modulation with a data rate of 2.8 gigabit per second and real-time processing. We use THz transceiver receiver hybrid front ends with gallium arsenide based MMICs, also 22 dBi gain antennas, and carrier frequencies of, as I said already, 300 gigahertz approximately. In our setup we have basically an AWG that creates the signals, IQ signals for the transmitters. Then we have our two downlink connections, where we then receive the signal, amplify in the baseband. Then we have our real-time scope, which samples the signal. And then we have our single carrier offline DSP, where we perform our offline signal processing. For the uplink, we have another AWG that creates the IQ signals. And then also after receiving, we again amplify the signal in the baseband, have two bandpass filters, and then our FPGA-based BPSK receiver, where we use then real-time processing and a bit error rate tester to see how the performance is. And so in our measurements we can then see that between those two use cases, THz broadcast and THz unicast, we can see a similar performance. It is error-free after FEC, and we can use a symbol rate of up to 32 gigabaud. And we reach a total transmitted data rate there of 50 gigabit per second. The limitation that we have here is our front-end bandwidth. For the uplink, we have a total transmitted data rate of 2.8 gigabit per second, and we also perform bidirectional transmission experiments, where we then used a downlink and uplink at the same time. Here we achieved a downlink data rate of up to 18.75 gigabit per second, and we used one-time BPSK modulation with 4-QAM modulation, so 2.8 gigabaud BPSK with a 8 gigabaud 4-QAM, and also the same BPSK with a 16-QAM with 6 gigabaud. And in both cases we saw a error-free transmission after FEC, and here we only have a limitation by a module internal crosstalk. Here we have some spectral overlap. And so we demonstrated those both use cases, and demonstrated this with our high capacity dual link prototype system. And we reached data rates of up to 50 gigabit per second in the downlink and 2.8 gigabit in the uplink. And we also developed and demonstrated our burst mode capable DSP, and also have shown a real-time implementation of the uplink DSP. Thank you very much for listening.